In this experiment, you will be carefully recording the emission line spectrum of several elements. When light is passed through a spectroscope, it separates into several distinct bands of color unique to the substance producing the light. By recording which bands of color, or wavelengths, are present from a light source, the elemental composition of that light source can be identified by matching the specific color bands to that of known spectra. In this experiment, you will be determining the identity of an unknown light source based on the emission line spectra of several known substances. The method you will be using is one of the methods scientists use to determine the chemical compositions of things that they cannot directly sample, like stars. Watch the following demonstration carefully and write down the steps to the procedure in as much detail as possible. The only material you will need for this lab is a spectroscope. The spectroscope passes the light through very small slits to separate it into distinct wavelengths or colors. The different wavelengths that make up an emission can be measured by the ruler inside of the spectroscope. You will record the number below each band of light with as much precision as possible. The number corresponds to the wavelength of light that you are seeing. To get started, you must first calibrate the spectroscope. To do this, you will examine the fluorescent lights in the lab and record the emission line spectrum details. Then, using the equations and tables found in your lab notebook, you will determine how far off your particular spectroscope is. If you switch scopes during the lab, you must recalibrate. Make sure to record the number on the scale under each band of color to the highest precision possible. Also, record the color and thickness of the band. If you don't get a clearly resolved emission line spectrum for the fluorescent lights in the lab, go to the lights directly outside of the lab. They may be closer to your scope and resolve more clearly. Hold the spectroscope close enough to your eye that the emission lines appear distinct. This may take some practice. When using the scope, stand 1 to 3 feet away from the light source. This is the best range for resolving the spectrum. One person can observe the spectrum and read off the measurements while the other person records. Switch responsibilities often so you can both practice using the scope. Take turns viewing the different lamps around the room. Record the spectral data carefully for each. When using the hydrogen lamp, be careful to follow the written directions and only turn the lamp on for 30 seconds. Then it must be off for 30 seconds, so record the spectral details quickly. Though you must remove your goggles to view the scope, you must replace them when not using the scope. There are still hazards in this lab. To view the emission spectrum of ions, your TA will burn some substances over a flame for a short time. Make sure to know when this is happening so you don't miss your chance to observe this spectrum. In addition to recording the spectrum of the flame, also record the color visible to your eye. This will aid in unknown identification later. Record the emission spectrum of your unknown and compare it to the spectra you have obtained from the knowns. The visible color and emission spectrum must match to be correctly identified.